Hello students, we are continuing with the chapter force and pressure. Okay, in the initial class we have studied about force. Okay, what is force and how with the interaction it works. Okay, now next we are going to study a force can change the state of motion. Okay, so if we are applying force to any object, its motion can be changed. How? Let us see with the help of an example. Okay. So you are taking a ball, okay, simple ball, on a concrete floor or on a tabletop, okay. Now you are applying force to it, okay. You are pushing it basically, okay. So what will happen? This ball will move forward, है ना? It will move forward with a speed. Now, it is moving only and then you are just applying more force to it. Okay? ज़्यादा force apply कर दिया. What will happen? Its speed will increase, isn't it? Its motion will increase. And then you are keeping your palm over here. Just for a while you are keeping. When it touches, what will happen? You will remove your palm. Okay? What will you see then, beta? When you remove the palm? Okay? That yes, the speed of the ball has been decreased. So, three stages you have studied over here. Okay? One, the ball was at rest. Okay? Here the ball was at rest. You have applied force to it. It started moving. Okay? It moved forward. Okay? With a speed. It means here it is moving with a greater speed. Okay? So here the motion of the ball increases, isn't it? Now, you had kept the palm, okay? So there was an obstruction for a while, the ball just touched your palm. What happened? Now, because you had kept your palm, you have created an obstruction. What happens over here? We see that yes, the motion decreases. Okay, motion decreases. With this you can take number of examples. Okay, here it is stating only that yes, what happens? This force can change the state of motion. Okay, here on the body which was at rest, okay, here motion was 0. Applying the force to it, started moving and the motion increased. Okay, when we applied more force to it, it started increasing, isn't it? And then when we kept the palm, okay, what happened? The force is decreased, thereby what happened? Here the motion decreases. Now let us see another example of change in state of motion. Okay, suppose a ball, okay, is coming and hitting a scale over here. Okay, what will happen? Here you will be seeing that yes, it will be changing its direction with an angle. Okay, so here it is moving towards the scale. Okay, and then when it touches the scale over here, it rebounds back, making an angle. Okay, so here we have seen that yes, when we have applied force to this ball, what happened? It has changed the direction. So when we see about the change in state of motion, okay, we can see it with the change in state of what? Speed, okay, or we can see with the direction. So when we talk about change in state of motion, it can be in the change in speed as well as change in direction. It can be either speed or direction, or it can be both. So when force is applied to any object, there is change in state of motion. So there may be a change in speed or there may be a change in direction. It depends, again I am saying it depends upon the net force acting. What is this net force? Okay, if anything is being applied, suppose here, okay, in the forward direction, okay, it will move forward. But yes, suppose if a force is also being applied from this side, okay, so what will happen? Will this move? Okay, if equal and opposite forces are acting from this side also and this side also, it will be in a stable condition, in a constant position. Okay, but yes, if the force applied from this side is more, it will move forward. But if the force applied from this side is more, then it will move in this direction. So it depends upon the net force which is more, either from this side or from the opposite side. Okay, so here we'll be seeing that yes, the direction as well as the speed. Okay, we see that yes, in the state of a change of state of motion, when we apply the force, there is change in speed as well as there can be change in direction. Now this experiment we have seen here that yes, change in state of motion. Okay, here we can see that yes, there is change in state of speed and as well as change in direction. With these experiments, we can also move further. Okay, how we can move further? If you can change the placing of this ball. Okay, if it is placed suppose over here. Okay, applying the force. Okay, and then hitting on this. Now naturally it will hit and move to here. You can see the direction is changed because it will also make the angle. Here also the angle is made while it is moving back. Okay, so this we'll be seeing that yes, totally the directions are changing. Okay, so here in change of state of motion, okay, the speed as well as the direction, we can see that yes, it changes, and this change in the speed and change in the direction only defines the change in state of motion. Suppose if the body is at rest, so what will be there? The speed will be what? 0 when it is at a rest. So there the motion is nil, so it is 0. So we will be saying that yes, this state of change in state is totally what? 0. Okay. So now let us study that yes, force can change the shape of the object. So if you are applying force to anything, any object, okay, it can change its shape. Okay, how can it change its shape? Let's just see. I am taking this bottle. Okay, now what I am doing, I am applying force to it. What I am doing, I am pushing it. Okay, let us see will it change its shape or not. Okay, can you see that it has changed the shape where I am applying the force to it, isn't it? So this is an example that yes, force can change the shape of the object. Okay, now some of the examples of the book. Okay, when you are kneading a dough, okay, making a dough, okay, what happened? You are kneading the flour and making a dough. You are applying force to it. Will you see that there is change in shape as when your palms goes inside the dough? Okay, just do it and see it. You will be seeing that yes, its shape is changing. Okay, another example from the book only. Okay, suppose a nail is there on the wall. Okay, and you are applying weight from one side. What will happen? Will it be in that position only or it will move? Isn't it? It is moving. Now, any elastic body if you are taking, applying force to it, naturally what will happen? It will change its shape. If it is totally solid, to change the shape it becomes difficult by applying force. But yes, if it is an elastic body, it will change its shape when we are applying force to it. Okay. So here, when we are studying about this force, we can see that yes, the function of this force, that yes, if we are applying force to any object and if it is at rest, it will move. So we can conclude that yes, by applying force, we can make an object move which is at rest. So we can make object move, okay, by applying force. So if it is at rest, the body is at rest, it can move if we are applying force. Okay. Second, we can change the speed, isn't it? Can change speed. Okay, So third we have seen, yes, we can change the direction. It can change the direction. And it can also change the shape, isn't it? It can change shape. Or you can also say that it can change any of this, okay? Along with speed, it can change the direction also, along with the shape, okay? So here, the basically force, we conclude that yes, it can make any body which is at rest, it can move, it can change the speed of the body, force can change the speed of the body, even it can change the direction and shape, okay? Now, let us study about the types of forces, okay? So when we talk about the types of forces, okay, so this force, okay, it is what? Divided into two, okay, or classified into two. Contact forces and non-contact forces. Okay. Now, what are contact forces? What we will be studying under contact forces, that is the muscular force and frictional force, okay? Friction, I am writing, or you can say frictional force, okay? Now, in non-contact forces, we will be studying magnetic force, and then we will be studying electrostatic force, and gravitational force. Okay. So now let us understand first these terms contact and non-contact forces. When I am saying contact, it means in touch. Okay. And when I am saying non-contact, not in touch. Okay. So contact forces, muscular forces. If I am using any force, okay, like if I am saying muscular force, okay, I am moving it with my hand, I am using my muscular force, okay, what will happen? This pen will move forward, okay. Frictional force, it is the opposing force, okay. Like here, suppose an object is kept over here, I am pushing it with my hand, okay, applying what? Muscular force to it, it will move forward, okay. Now, here, this object again, okay, I am pushing with a force. Here also from opposite side a force is acting, okay. So this force will be saying as what? Frictional force, okay. It means it is resisting it to move forward. Any object which is being kept, okay, and at any place, okay, if you are applying or pushing it, it will move forward, but many of the object you will be seeing that it is not moving forward. Why? And opposite force is also working on it, okay, and that opposing force is as much as great as you are pushing it forward, and as the result it is not able to move. Sometimes you will be seeing that yes, the box is moving somewhat front, but very slightly. There what is happening? Your force is more than that opposite force, and that opposite force is known as what? The frictional force, okay. And sometimes you'll be seeing no, it is not able to move. Whatever force you are applying, it means the opposing force is more, it is not allowing the body to move forward. So by this you can understand this muscular force, anything you are applying force to it, okay. Like the bullock cart also, you will see the bullocks are applying what? Force to the cart, so that it is pulling the cart forward, isn't it? That is what? Muscular force. Okay, the animals which we are using, they are just taking the things, the carts and other things with it. Okay, these are all muscular force. The force which you are applying, that is also muscular force. Okay, now frictional force, that is the opposing force to the force which you are applying. So wherever it is, anything is kept, okay, if your force is more than that frictional force, the body will move forward. If not, what will happen? It will not move. So these two types of forces, muscular force and the frictional force, you have understood. Frictional force, it is the opposing force. Okay. Now, magnetic force. Okay. It is a non-contact force. Why we are saying non-contact force? Okay. Suppose you have taken a magnet. Okay. Here it is north position, here it is south position. Okay. Now, you have taken 3-4 pencils, okay, and on that you have kept another magnet, bar magnet, okay, and here it is north and here it is south. What you will be seeing, that yes, it is not in contact, but this magnet is moving this side, or it is being attracted towards this magnet. How you will be seeing it or feeling it, this will also roll, okay, in this direction, this pencils, okay. Now, taking another bar magnet, okay, north, south again keep pencils, above that keep a bar magnet, this time south and north. Now you will be seeing that yes, what is there? These pencils are rolling towards this side. The direction is this side. It means it is moving back. Okay, so here there is no contact, but yes, we can see the motion is being done over here while we are seeing these pencils are rolling. Okay, but here nothing is in contact, so these are non-contact forces done with the help of a magnet. They are experiencing what here? These two magnets, what they are experiencing? The magnetic force, okay, and yes, they are non-contact forces, just because we all know that yes, when unlike poles are there, they attract, when like poles are there, they repel. So here they are being pushed apart, and here we are seeing yes, they are unlike, okay, poles, so here they are pulling towards each other. Okay. Now talking about the electrostatic force. Okay, what is this electrostatic force? We are saying this word, it means charges are coming. Let us understand with the help of an example. We are taking a plastic straw. Okay, and we are cutting it into 2 equal halves. Okay, one half we are hanging it. Okay, another we are holding it. Okay, what you have done with this half? You have just rubbed it with the paper. Okay, so when you rub it with the paper, it acquires charge. Okay, now bring this charged straw towards this hanging one. Okay, as this one is, this which you have hanged it, it is not having any charge. What will happen? It will attract. Okay, but second step, what you are doing, you are rubbing this one also, which is being hanging also, you are rubbing it with the paper. Now this is also charged, which you are holding is also charged. What you will be seeing, will it attract? No, it will not. Okay, it will not attract. And as a result, here you are seeing that yes, it is being pushed apart. Okay, and in the first case we have seen that yes, when the one was charged, another was uncharged, it is being attracted. Here also forces are acting, but which type of forces it is? A non-contact force. Here nothing is in contact, then also force is being experienced. Coming to the gravitational force. Okay, if you drop anything, okay, what happens? If I just lay this cap, what happens? It falls down, isn't it? Why it is happening? This is because of the gravitational force of the earth. The earth is applying a force Okay, it is pulling the thing towards itself. When we talk, we are saying about this gravitational pull of the earth. Okay, that is of the earth. We can understand anything if we are leaving it, it falls down because a force is there which is applied by the earth, which is bringing the things towards itself. But yes, when we talk about any object, beta, all are having this gravitational force in them, but it is too small. Okay, so this is about the gravitational force, and here we have seen that yes, there is no contact, so they come under non-contact forces. So this is all for today. Good day, take care.